Hello everybody. Last time we learned how to simplify rational expressions by finding the greatest common factor and by also factoring quadratic expressions in numerator and denominator, and then we found some common factor that could be simplified. So this process is going to be useful in multiplying a rational expression, and then we're going to talk also about dividing rational expression. So for today we're going to focus on multiply rational expressions. I just want to remind you that when you multiply expressions in terms of a fraction, you need to multiply the two numerators and you need to multiply the two denominators. So I'm going to show you some examples. You should try this example by yourself first, and then as always check with me. Okay, so here is example number 1. Alright, so we want to multiply these two rational expressions. So the first one is 6 times r plus 2 divided by 20. And we want to multiply these two rational expressions by this rational expression by 4r divided by 6 times r plus 2. Now, essentially you can proceed with two different methods. You could multiply the two numerator first and the two denominator, and then try to simplify from there. Okay? So that's one way to simplify this rational expression. But if you notice that there is already a common factor between numerator and denominator, you should already simplify that. Okay? So let me show you a very simple example with number, and you better understand what the two possible methods can be. Okay? So let's assume I want to simplify this. I have a 5 divided by 2 times 3 divided by 5. Okay? So it's a very simple example. So one way to simplify this product of fractions would be to multiply the two numerator first. So 5 times 3 will be equal to 15, and then 2 times 5, which is equal to 10. Once you get the final answer, you could simplify this, because 15 divided by 10, well, this becomes 3 over 2, since 15 and 10, they're both divisible by 5, so you would end up with 3 divided by 2. So that's one strategy you can use. But I believe that there is a better way to simplify this product of rational expression, which is simplify before you multiply. You can always do that because there is a product here, okay? And what this means is that you could actually, so here is a different strategy. 5 times 2 times 3 over 5. Before you multiply, you can actually simplify the 5, because 5 divided by 5 is 1, and therefore you immediately end up with 3 over 2. So this most of the times save you some energies, right? Some time in working these problems, and therefore you end up with the same answer, but you avoid some steps. Okay, so you can do this with a shortcut. So simplify before you multiply. So anytime we have a product, we can actually do that. So I think this second strategy is most convenient. So in this case, therefore, instead of multiplying the two numerators, multiply the two denominators. If we see that we can simplify, that we have a common factor, we should do that. We should simplify this. In fact, r plus 2 divided by r plus 2, well, it's a common factor, so we can cross them out, so this simplify to 1. And then the same thing for 6 divided by 6, this simplify to 1. So now we are left with 4r divided by 20, but we can still simplify this, right, before we even, rewrite. So, well, 20 is divisible by 4, so 4 divided by 4 is 1, and 20 divided by 4 is 5. So what's left? Well, in the numerator we have r, and the denominator we just have 5. So r over 5 is your simplified expression. Okay, let's look at some other example. Something looks more complicated, but if you use this strategy I just showed you, it can be done very quickly. So what we have here is 7n squared times n plus 4, and then then this divides by n minus 3 times n plus 4 times the second rational expression, which is n minus 3 divided by n plus 8 times n plus 6. So before we multiply, okay, we could again multiply two numerators, two denominators, but understand that this becomes tedious, so it's much better to simplify before we multiply, if we can, of course. In this case we can, because we can simplify the n plus 4 with n plus 4 as long as n is different than negative 4. Well, remember, I didn't mention this in the first problem, but remember the denominator must always be different than 0. So all of these operations we're performing, they are allowed as long as denominator is different than 0, which means, like for example, for this second problem we need to have n different than negative 4, because negative 4 plus 4 will become 0. N from this must be different than 3, because 3 minus 3 becomes 0. N plus 8 must be different than 0, and therefore n different than negative 8, right? And also this n plus 6 must be different than 0, which means n must be different than negative 6. So as long as these values, this denominator, are different than 0, then we can simplify. So this n minus 3 is not in parentheses, but doesn't change if we put in parentheses, can actually be simplified with this n minus 3. And that's it. So now we are left with a numerator, which is 7 times n squared, and then divide by n plus 8 times n plus 6. Okay, okay, let's try an additional problem, number 3. So here we have n times n plus 1 divided by 7m, and we want to multiply this by 9 divided by 8 times n plus 1. Okay, what do you think we're going to get from here? Well, notice like 8 and 8 can be simplified, they are the same. n plus 1 and n plus 1 can be simplified as long as m is different than negative 1. Of course, we want also m to be different than 0. So we end up with 9 divided by 7m, because this cannot be simplified, right? So this is your final division, your final simplified expression. Let's work number 4. Okay, let's see. Let's do something a little bit more challenging now. Okay, so we have 7n divided by 24n cubed minus 64n squared. And we want to multiply this rational expression by 9n minus 24 divided by 7n. Okay, so what do you think is going to happen in this case? Okay, so I suggest that you try to work this by yourself. Okay? Okay, so notice how 7n is a common factor between numerator and denominator, so it's simplified to 1 as long as n is different than 0. And then here I have 24n cubed and negative 64n squared. Here I have a positive 9n minus 24. So do this simplify? Maybe yes, maybe no. So what we should do is find the greatest common factor, right? And then see if something simplifies. So what we have so far is a numerator which is 9n minus 24. And then this is divided by 24n cubed minus 64n squared. Okay, it can probably still be simplified. Well, let's see. Let's take a look at the numerator, and let's think about the greatest common factor between 9n and negative 24. What would be the greatest common factor between these two terms? Well, 9 and 24, they are both divisible by 3, right? So I can factor out the 3, and then I end up with 3n, right? Because 3 times 3n is 9n, and then minus 8. Okay, while here at the denominator, well, what's the greatest common factor between 24 and negative 64. Well, there is also n cube and n square, right? So if you only look at the number 24 and 64, they are both divisible by 8, so that should be the greatest common factor. And between n cube and n square, the greatest common factor will be n squared, and therefore what's left inside parentheses? Well, 8n squared times what is going to give me 24n cubed? Well, that would be 3, or better 3n, because 3n times 8n squared is going to be 24n cubed, and then 8n squared times what is going to give me negative 64n squared? Well, the number will be minus 8, okay? And now, notice how we end up with 3n minus 8, which is a common factor between numerator and denominator. So as long as n is different, in this case then 8, yes, 8 over 3, then this quantity can be simplified. Of course, we want also n to be different than 0 because of this n squared. So we end up with 3 divided by 8n squared, which is your final simplified expression. Okay, so let's look at some other examples. Alright, so let's look at this one, number 5. So now I have x plus 7 divided by 7x plus 35 that multiplies x squared minus 3x minus 40, and then all of these divided by x minus 8. Alright, so far it looks like there are no common factors, so let's see what we can do. Let's try to factor out whatever we can. So, of course, there is nothing I can do for this x plus 7, so we keep it. But how about the 7x and 35? Is there a greatest common factor there? Yes, because 7 is in common between 7x and 35 is the greatest common factor, so 7 can be factored out and we end up with x plus 5, because 7 times 5 is 35. How about the second rational expression? Well, there is nothing we can do about x minus 8, but we can factor out the numerator, so we have an x squared minus 3x minus 40, okay? Okay, something happened with my pen, so let's see if I can recover the problem, okay? Let me rewrite it, okay? So it was x plus 7. So remember we said there was a 7 here, x plus 5, and then times. So we wrote the x minus 8, and then in the numerator there was an x squared minus 3x minus 40. Okay, how can we factor this x squared minus 3x minus 40? Well, it's a quadratic expression, so the leading coefficient is 1. Can we find two numbers whose product is negative 40 and whose sum is negative 3? Well, how about positive 8 and negative 5? So 8 minus 5 is negative 3, 8 times negative 5 is negative 40. Okay, so let's rewrite what we got so far. So we have x plus 7 divided by 7 times x plus 5. Okay, and then, oh, I'm sorry, this was a negative 8 and positive 5, my bad, because we need to get a negative 3. So negative 8 plus 5 is negative 3. So the numerator now becomes, we can use the shortcut because leading coefficient is 1. So we can immediately write this as x minus 8 times x plus 5, and then we want to divide this by x minus 8. So as long as x is different than 8 and x is different than negative 5, this factor can be simplified with this. This x plus 5 can be simplified with this to 1. So we are left with a rational, well, it's not anymore a rational expression, so the simplification becomes just a linear expression. There is no x at the denominator, so we have x plus 7 divided by 7. Okay? Okay, let's try this problem. Now we are number 6. So we have a 20 a squared minus 100a, and then divide by a minus 1 times 1 over 16a cubed minus 80 a squared. Alright, so let's see if we can simplify this. Let's start with the first numerator, with this one. Notice how there is a greatest common factor here between these two terms. They both have a in common, and they're both divisible by 20, right? So the greatest common factor should be a 20a, then multiplies, well, we must get an a squared from here, so there must be an a, and then minus 5 by itself, because 28 times negative 5 is negative 100a, and then we need to divide this by a minus 1. And then here we have times 1 over, well, 16 and 8, they both have a greatest common factor of 8, and then between a cubed and a squared, we're going to pick up a squared, so this multiplies 2a minus 1. So 2a minus 1. Let's see. So, is there anything that we can simplify? Well, let's see. The a minus 1 here is going to stay. Well, we can simplify this a with the a squared, right? And then we have this 20 and this 8. Well, 20 divided by 8, well, they're both divisible by 4, so 20 divided by 4 is 5, and then 8 divided by 4 is 2. Okay, so what we are left with is a minus 5 times 1, right, which stays 1, and then we have a minus 1 times a here outside, and then we have a 2a minus 1. So this cannot be any more simplified, so this should be the final expression. Okay. Alright, let me show you two additional problems. Let's go to number 7. Okay, let's look at this one. It looks interesting. So 21x squared minus 21x divided by 18x squared minus 18x, then multiplies 6x divided by 6x squared. Okay, well, of course, there is a common factor in the numerator, which is 21x, so we can factor out this, and then what's left? Well, we need to get an x squared, so x is left, minus 1. We can do the same thing at the denominator, right? We can factor out 18x in this case, and we're going to have an x minus 1 in parentheses. And now 6x and 6x squared can be simplified, right? How can be simplified? Well, what does it mean 6x squared? It means 6x times x, right? So this and this simplifies as long as x is different than 0. This and this can be simplified as long as x is different than 1. Then this x can be simplified. And then 21 and 18, they're both divisible by 3, so it becomes a 7 divided by 6x. And this is the final rational expression. It's a rational expression because x is at the denominator. Okay, so let's work one last problem. Problem number 8. Alright, so here we have 6n plus 6 divided by n plus 9. Then multiplies n squared plus 6n minus 27. And then this is divided by 6n plus 6. Okay. Can we simplify this? Well, notice how we have a 6n plus 6 and 6n plus 6. Now you may have thought probably to factor out the 6 first, right? And write this as 6 times n plus 1, right? Which we should do, right? We can do it. But then this is the same term, right? So instead of factor out the 6 in this case, since they are the same, we can just simplify them, right? So there is no need to factor out the 6. You can immediately simplify. So we're left then with this quadratic expression, the numerator, and the n plus 9. Let's see if we can factor out this quadratic expression. We need to find two numbers whose product is negative 27 and whose sum is 6. Can we find these numbers? Well, let's see. How about positive 9 minus 3. 9 times negative 3 is negative 27, and 9 minus 3 is 6. Again, leading coefficient is 1, so we can write this as n plus 9 times n minus 3, right? And then there is still an n plus 9, right? N plus 9, and therefore this and this can be simplified. So your final expression, which is not rational expression, is a linear expression, is n minus 3. Okay? Alright, so I hope that this process is clear. With this, you should be able, you should practice on this problem a little bit longer, probably also. You can find some more challenging problem even if you just Google rational, so if you Google multiplication with rational expressions, and then I strongly suggest that you work the ALEKS problems, and make sure please you complete this by the deadline. As always, let me know if you have any questions. So what we're going to do next is going to be divide the rational expression. But keep in mind that dividing a rational expression is it can be easily converted into a multiplication, because dividing fraction, it means multiply by the reciprocal, right? So as long as this is clear to you, you should have no problems with dividing rational expressions. Okay? Alright, so let me know if you have any question. Okay? Talk to you later. Bye bye.